Hello everyone, welcome back to my YouTube channel again. So in this video, let us discuss about a statement and explanation of Thevenins theorem. Okay, so you can see the statement, a simple statement. Just remember, try to remember. Whatever the circuit they are given in a numerical, you need to convert that into an equivalent circuit so that you can, in the form of practical voltage source across a load. Okay, so that you can see here. A linear two-terminal circuit can be replaced by an equivalent circuit which is consisting of one voltage source is in series with a resistor when V is represented as Thevenin's voltage, that is open circuit voltage at the terminals, and R is represented as Thevenin's resistor or else equivalent resistor at the terminal, so that whatever the circuit they are given, you need to convert and you need to transform that circuit into the form where it consists of VTH is in series to the RTH, VTH is in series to RTH or R equivalent across the load terminals. A and B are load terminals across load terminals. So if you want to find current flows to these load terminals, that is represented as IL. So that IL is given by VTH divided by, suppose if the terminal of the load is having a RL, in that case RTH plus RL. That's it. So steps to solve the problem. So you need to convert the circuit in the form of practical voltage source, that is VTH is in series with RTH across load terminal, so that the main objective of this particular theorem is to find VTH, that is nothing but open circuit voltage. So the first objective is to find VTH, that is nothing but Thevenin's voltage or else open circuit voltage. Open circuit voltage or Thevenin's voltage. Thevenin's voltage. That is nothing but voltage across A and B terminals. That is nothing but load terminals. Suppose if there is a load RL, so in that case you need to replace that load by short circuit. Sorry, you need to replace that load by open circuit. Then you need to find VTH. So let us consider one example. Consider a circuit. You can see there is one circuit. I'll consider this plus minus. Suppose if it is having some V1, there is some resistor R1 and R2 is connected across a load or else R3. If they ask you to find current flows to the R3 using Thevenins theorem, so this R3 will be act as a load resistor and current flows to this will be act as IL. In that case, to find the value of VTH, replace RL or R3 by open circuit and find voltage across the open circuit terminals. So you can observe the circuit now. The circuit that will be looks like this. So considering that circuit, I will redraw the circuit again for to find VTH. The V1 as it is. Then there is a R1, R2. Sorry, this is not there. R1, R2, and the load terminals A and B. Suppose this is the load and terminals. If you want, you can notate load terminals A and B. So now this RL is replaced by open circuit. So now voltage across this is now VTH. You need to find this VTH. Okay, that is also called as open circuit voltage. You need to find this. Okay. So now we can use any reduction techniques to find the value of VTH. So now what is VTH? Voltage across R2 is your VTH. This is VTH. So you need to find the value of VTH. To find the value of VTH, you should know current flows to R2. So now the circuit which will be act as a series circuit, so that current flows to this. I'm just assuming that as I is flowing, that I is flowing through the R2 also. So this I is given by V1 divided by R1 plus R2. Once after getting the value of I, say it as some A amperes, or else if you're getting some value of I as X amperes, you need to substitute here. VTH is given by voltage across R2 is VTH now. Because A and B terminals open, current flows to that terminals is zero. Only the Thevenin's voltage or else open circuit voltage that will be present. It is given by I into R2. Like that, you need to find the value of VTH in terms of volts. So this is a step to find VTH. Replace a load resistor by open circuit and find the voltage across open circuit terminals A and B. Similarly, the second point is you need to find RTH. That's nothing but equivalent resistor. So now to find RTH, this is a first case, and the second case is to find RTH, or else to find equivalent resistor, or else Thevenin's resistor. To find R equivalent, replace all the independent sources by zero. If there is a voltage source, replace. Before that, to find RTH, replace load resistor or R3 by open circuit, then find RTH from open circuit point of view. To find that, if there is any voltage sources, or else replace voltage sources by zero, short circuit, and current sources are replaced by open circuit. So now we can see this. To find RTH, you can observe the circuit diagram. So in that circuit diagram, you need to replace that R3 or else RL by open circuit. You can observe the circuit diagram. Replace V1 by short circuit. V1 is short circuit. If there is a current source, open circuit. R1 as it is, you can see replace RL by RL or R3 by open circuit, then find RTH from open circuit point of view. R1 and R2, and replace load resistor by open circuit. From this point of view, you need to find RTH. So RTH is nothing but now R1 is parallel to R2. So that RTH or R equivalent is given by R1 into R2 divided by R1 plus R2. Once after knowing all these, you need to draw equivalent circuit diagram of Thevenin's theorem. Then you need to find IL. So now third step is to draw equivalent circuit of Thevenin's theorem. That's nothing but RTH plus minus VTH is series to the RTH across load resistor. So now what is load resistor for this circuit? That is R3. Then current flows to the load resistor is IL. So that IL is given by, once after knowing the values of RTH and VTH, you can get VTH divided by RTH plus R3 or RL load resistor, R3 or RL. So this is the procedure to understand the problems of Thevenin's theorem. If you're having any doubts regarding this, feel free to write in a comment box. You can observe here. As per the Thevenin's theorem, you need to replace any circuit by consisting of a voltage source VTH in series with RTH R, that is a Thevenin equivalent resistor, across load. To find the value of VTH, replace load by open circuit and find the voltage across open circuit terminals. Then to find RTH, if there is any voltage sources, replace that by short circuit. If there is any current source, replace that by open circuit. Then replace load resistor or else replace load by open circuit and find the equivalent circuit or else Thevenin equivalent resistor or Thevenin resistor from open circuit point of view. Then after knowing all these things, you can draw the Thevenin's equivalent circuit diagram. Then you find current flows to the load. So this is how you need to understand. If you're having any doubts regarding this, feel free to write in a comment box. So if you really like this video, kindly do subscribe and share maximum. Thank you so much. Have a nice day.